Hello everyone. So today we will be discussing more about permeability, and we will be discussing about the various factors that affect the permeability or like relationship of permeability with other factors. So let us go one by one. So let us discuss the effect of void ratio on permeability. Okay, now permeability, as we all know, it is denoted by mainly by the term K, which is what? Coefficient of permeability. So, whenever we talk about permeability, we are actually talking about K. Okay, we are actually talking about K when we are talking about permeability. Now, uh, let us see for the first of all effect of void ratio. Now, assume that uh, you have a soil with void ratio E1. Okay, you have a soil with void ratio E1 and having a permeability of K1. Okay, this K. Suppose in first you have a soil of void ratio E1 and permeability K1. Then suppose due to some compaction or expansion, the void ratio of the soil changes and it becomes E2. Okay, then what will be the new permeability K2 for the same soil? Okay, the soil is same, but due to some expansion or contraction, the volume of voids got a little bit changed. Okay, or the volume of solids got a little bit changed. Due to some volume change, the void ratio changed. So E1 became E2 for the soil. So now initially the permeability was K1. What will be the new permeability? K2. So that can be determined by a relation which is let me take blue ink today. Let us write the equation now. So K1 by K2 is equal to C1 E1 cube by 1 plus E1 divided by C2 E2 cube by 1 plus E2. So this is the relation. Okay, now E1 you know, K1 you know. After some volume change that happens in voids or solids, E2 you will be getting. Then what will be K2? You can get from this relation. So now you need two more values which are C1 and C2. What are these C1 and C2? So these C1 and C2, let me take a new screen. These C1 and C2 are shape factors. Okay, and it depends on the manner of packing of the grains. That means the soil particles. Okay, so I'll write it down. Depends on the manner of packing of the grains, or grains means the soil particles. Okay, and also the shape characteristics of the pores. Pores means voids. Okay, now when we look for sands, okay, when we look for sands, sandy soil, the C value, okay, it does not changes. It does not change much. Okay, so C1 will be equal to C2. So whenever you do some changes in a soil, when like this C value does not change that much. Okay, so initially if the C value is C1, if finally the C value is C2, for sands the values will not differ much. Okay, so it will be treated as equal. The values vary only slightly, so we take it as equal. Okay, so for sense, initially I just repeat. Uh, Initially, if the C1 shape factor is C1, and after some volume changes in the soil, some like volume changes happening, the if the value becomes C2, then this C2 C1 are not so different. Okay, they are almost having the similar values. Okay, so what will be the equation that you get for sense in this case? For sense, what will be the equation that you get? So I will write it here itself. So if I write down the equation, let me use this screen itself. For sense, uh, k1 by k2 is equal to c1 e1 cube by 1 plus e1, c2 e2 cube by 1 plus e2. So it will be equal to c1 e1 cube by 1 plus e1 into 1 plus e2 by c2 e2 cube. So c1 and c2 we can cancel, because for sense we take c1 equal to c2. Okay, so finally what will the new equation become? K1 by k2 is equal to e1 cube by 1 plus e1 into 1 plus e2 by e2 cube, isn't it? So now uh, what will be the another way of writing it? K1 is to K2 E1 cube by 1 plus E1 is to E2 cube by 1 plus E2. We can also write it like this. So please try to understand this. Okay, so this is the equation that we end up getting. Okay, K1 is to K2 is equal to E1 cube by 1 plus E1 is to E2 cube by 1 plus E2. Okay, sometimes another relationship is also used. Okay, so please try to first of all I'm just repeating. Please try to remember the steps how we have got it. So first, k1 by k2 is equal to c1 e1 cube by 1 plus e1 c2 e2 cube by 1 plus e2. So ultimately we are just simplifying it, and then c1 c2 gets cancelled. Okay, and then ultimately we end up like this, and ultimately we end up in this manner. Okay, now in some cases another relationship sometimes used is k1 is to k2 is equal to c1 e1 square is to c2 e2 square. Okay, now this is sometimes used. Now for sense it will be again like c1 c2 get cancelled, so k1 is to k2 is equal to e1 square is to e2 square. Okay, now these equations are not reliable for seals and clays. Okay, these equations are not reliable for silt and clay. So many people have tried to develop some suitable similar relations for silt and clay. Okay, just like the relations that we have been discussing in the past few minutes. So similar relations the investigators tried to develop for like E and K for seals and clays. So and they ended up with getting this relation for seals and clays. The relation that they get was so this one. So you need to understand this. Okay, log of 10 base k1 is to log of 10 base k2 is equal to e1 is to e2. So please go through these notes, whatever I have discussed. Now let us go to a new screen. Again, I will be using blue color. Now, measuring permeability K. Okay, measuring permeability K by using falling head test and constant head test was done in what? Laboratory. Okay, these are the ways, falling head test or constant head test. These are the ways of measuring the permeability in laboratory. Okay, and if we want to determine permeability in the field, then we cannot do it using falling head and constant head test. Okay, so if we want to do the tests in the field, then we have to do tests which are called as pumping tests for field. So you have to first be clear with the thing that value of K for in laboratory we determine by constant head and falling head test, and in field we do the pumping tests. Okay, and uh, you see, permeability values are needed in various problems. Okay, which may involve drainage of excavations. Okay, suppose you are this is a soil surface and you are excavating something like this in the soil. Okay, you are doing some excavation like this. Okay, this is the excavation you are doing. So what will be the like if you are doing this excavation for water, for passage of water, isn't it, like drains and all. Okay, and you need to be aware of the fact that how much water from through these excavations, when the water will pass through these excavations, how much water will enter the soil, or some water will seep through the soil, isn't it? So that depends on the permeability. So that's why permeability values are often needed in problems which involve drainage of excavations. Okay, so when water is going through the drains, so water will seep through the drains into the underlying soil. So it will seep through only because of the permeability. And for that, for knowing about more in details about the seeping of water to the underlying soil through the excavations, we need to know the value of permeability. Okay, now again, we also need to know the value of permeability for determining reservoir storage losses. So, what do you mean by, first of all, reservoir? Okay, so reservoir is also like one of my favorite topics. So the thing is that when you make a dam, suppose from the top view you are seeing, from the top view, suppose this is the dam, this is the dam from the top you are seeing. So this is the suppose path of water falling. So behind the dam, if you have seen gone to Meghalaya, you have seen the reservoir, isn't it? Big reservoir. I will not tell the name. If just before reaching Meghalaya, you see the reservoir. What is the name? Just guess. It's a place where people sometimes stop their car and click photos also. Okay, there is a place where people stop their car while they go to Meghalaya and they click pictures. So that is a big reservoir. Okay, so I will not tell the name, you guess it by yourself. So generally the thing is that the reservoir is a large area where the water is stored. Natural storage area, okay, where the water is stored. It's not an artificial storage area, it is a natural storage area. And this water ultimately moves on through the dams, okay, and then electricity is generated. Okay, so this is the dam. So if the soil is very much permeable, then whatever water is stored in the reservoir, it will seep through the soil inside, isn't it? That means if the reservoir soil has too much of permeability, then it will not be able to store much water because the soil will leak through the soil inside. Okay, so just imagine this is the reservoir, okay, having this level of water, okay, uh, and the soil here is very much porous, then the water will leak inside, isn't it? So the water level will ultimately decrease. The water level will now become here. From this initial level, it will go here. So ultimately, there will be some reservoir storage loss. So for studying about how much losses are happening in reservoir storage, we need to know about the value of permeability of the soil in that place. Okay, so reservoir storage loss. Okay, these things are studied, and for that we need the value of permeability. Okay, so what is the appropriate field test which is done for uh, doing this, for calculating the permeability in the field? So let us start with the first one. So field test, start with the first one. So uh, suppose this is the level of soil here. Okay, this is the level of soil here. Then what we do is we construct a well. We construct a well like this. Okay, and suppose this is the top surface of the ground. This is the top surface. This is the top surface of the ground. Okay, now suppose this is the initial water level of water in the soil. Okay, then when we pump out water from this well, okay, with a rate of Q, okay, we try to start pumping water from this well, okay, until the rate becomes Q, constant rate Q. Then what will happen? The water will get depressions like this. Okay, so I will make a much clearer picture. So water will get depressions like this because the water is getting pumped out. Initially the water level was here. Okay, now the water level gets depressed. Okay, now what we do is we construct two other observation wells. Okay, like this. Two other observation wells we construct here. Okay, and what we do is we see the depth of water, okay, in the two observation wells. Okay, so let me construct it a little more farther away. Okay, let me do some bit of modifications, then it will be much better to explain. Let me construct another observation well here. I need some space actually. So now, suppose the height of the first observation, the water in the first observation is h1, and the height in the second observation well is h2, and this observation well is at the distance of r1 here, and this is the well which is at the distance of r2 here. Okay, so now where this depressions, we will be able to know the level of water from here. From the depressions we will be able to calculate. Okay, so how will we find out the permeability from this situation? It will be calculated by the formula K equal to 2.3 Q by pi log of 10 base, sorry, log of 10 base r2 by r1 divided by h2 square minus h1 square. So you will construct the observation wells. These are the two observation wells at a distance of r1 and r2 from the center of the main well. This one is the main well. Okay, uh, so when you are like pumping out water at a constant rate q, there will be depressions, and the depressions you will see h1 and h2 in the two observation wells. Okay, so when you get these values and r1 and r2 you already know, you can and you know the rate of pumping also because you are the one who is pumping it out, so you can find out the value of k. Alright, so k is 2.3 q by pi log of 10 base r2 by r1 divided by h2 square minus h1 square. Okay, so that is what you need to know from here. In the next video I will discuss more about another field test which is a little bit similar. Okay, a little bit, actually I should say a little bit different, okay, from this one, and the equation is a little bit different, mostly same but a little bit different. So that I want to keep it for the next video. Thank you very much.